Okay, 7.4, reasoning using slope fields. So it says, identify the particular solution that goes through a point. The figure to the right shows the slope for the differential equation dy dx is equal to 1 minus xy. Sketch the graph of a particular solution that contains 0, 2 and label that as point A. Okay, so that's what I'm going to do. I'm going to find 0, 2, which is up here. I'm going to label this A, and I'm going to trace, okay, the particular solution by following those slopes. Okay. And then I'm going to do the same thing for B, and B says sketch the graph of a particular solution that contains -1, -2, so right here, and then label that point as B. So here's B, and then again, following the slope fields, I get something that looks like this. Okay. So looking at number 2, which is a AP type question, I have that the slope fields for a certain differential equation is shown to the right. Okay, which of the following could be a solution to the differential equation with the initial condition y of 0 is equal to 0? So first, just looking at the slope field, I want to identify some things here. So the first thing I can do is I can look at that initial condition 0, 0 and plot that point. So 0, 0, and then kind of just trace around what that slope field is looking for that particular solution. Okay. Another thing that I want to point out is notice right here where I have kind of like a gap. Okay, there's no slopes recorded in this area. So this area is actually representing an asymptote. More specifically, a vertical asymptote at x plus 2. Okay. And so looking at each of these choices, since I identified a vertical asymptote at x plus 2, that means I should have an x plus 2 on my denominator. Okay, so this one, and then technically this one, because x plus 2 times x minus 2 is the same as x squared minus 4. However, since this mentions x minus 2, this is suggesting that there is another vertical asymptote over on this side at 2. Which if you look there, we have slopes going through there, so that means there is not another vertical asymptote. So A is not a possible answer. And then we look at C. For C, we don't have a denominator, but we kind of have that x plus 2 up there. So let's see what would happen if we plug in 0 for x and see if we get 0 for y. So e to the 0 plus 2 is e to the second power, which is not 0, so it can't be C. So that means the only possibilities we have here is B and D, and then looking at the numerators, we have to remember what each of the functions resemble. So for B, tangent of x, recall, looks something like this. And I know it's not going to be perfect, just a sketch. And so looking at this diagram, okay, in respect to the vertical asymptote, does that match this? Okay, it does not, which means it's not B, and the only thing it could be is D. Because notice on the numerator we have x squared, and x squared does resemble that positive parabola that we see off to the right. Okay, number 3 says consider the differential equation dy dx is equal to x plus 1 over y and its slope field shown. Describe all points in the xy plane where y is not equal to 0, for which dy dx is equal to -1. Well, they give us dy dx in equation and in numerical, so I'm just going to go ahead and set those two equal to each other. So I have -1 is equal to x plus 1 divided by y. Okay, and since this is in terms of y, where y cannot equal 0, I'm going to go ahead and get y by itself. And when I do that, I'm left with y is equal to -x minus 1. I'm now going to take that equation and find that on the slope field. So y equals -x minus 1. So it's going to go through here, negative slope, so it's right here. Notice that that line where I have y is equal to negative x minus 1, all of those slopes are negative. So I'm going to say all points that fall on the line y is equal to negative x minus 1 has dy dx less than 0, or in other words, the slope is negative. Okay. And then last one, number 4, says explain why the following could not be a slope field for the differential equation dy dt is equal to negative 0.3 times y. Well, there's multiple answers for this, meaning there's multiple ways you could justify it. For me, the easiest way is to look right down here where y is equal to 0. Okay, so this tells me that if y is equal to 0, then dy dt should be equal to negative 0.3 times 0, which is 0. Which means if I look at the line that I highlighted, all of those slopes should be 0 slopes or horizontal lines. But since not all of them are horizontal lines, this proves that this is not the slope field for dy dt. So I'm going to write that. So, however, all slopes in the slope field at y equals 0 are not 0. Okay, more specifically, these ones towards the end all have negative slopes.